For part 2, we'll explore discrete probability distributions. Okay, so let's say suppose an instructor gives a 5-point quiz or a 5-question quiz to a class of 25 students. So just a summary of the results, 7 students didn't answer any of the questions correctly, 2 answered 1 correctly, 5 answered 2 correctly, 6 answered 3 correctly, 4 answered 4 correctly, and 1 answered 5 correctly. A probability distribution, instead of creating a table where X is the number correct and we're just counting maybe the number that how many students got each of those correct, a frequency, we'll do a relative frequency instead. And a relative frequency is really just a probability. So in other words, 0.28, or in other words, 28% of those students got 0 correct. I just did that by doing 7 divided by 25, right, because there's 25 students. Let's see, 2 answered 1 correctly, so 2 divided by 25 gives you 0.08, etc. So I created this relative frequency table, or probability distribution, where X is just the number of correct answers, and P of X is just the proportion of the class that got X correct, or the probability that if I were to randomly select a student, that student would have gotten that many correct. 2 ways we can graph this. We've already seen a histogram, and that would be okay. Histograms are technically supposed to be used for continuous variables, but you could use it for a discrete variable, and that's okay. Alternatively, we can do a point representation because only certain numbers are possible, so we don't have to make the bars touch each other, in other words. Either way is fine. They're both showing the same information and show the same picture. Okay, a few notes about probability distributions. Each probability in a probability distribution has to be between 0 and 1 inclusively. In other words, 0 and 1 are included as possible results. And we explored this before when we talked about probabilities. In other words, you can't have a probability that's negative, and you can't have a probability that's more than 1, meaning that there'd be more than 100% chance of something happening, and that can't happen. So, and then the second rule is that if you add up all the probabilities, they have to sum to 1. In other words, we have to be including every possible option in the sample space when we talk about the probability distributions. And no outcome, no person could be in more than one group. All right, so let's explore this example. And let's just explore which of the following are probability distributions. All right, so looking at this first one. All right, so you see here that we have 0.2, 0.2, 0.2, 0.2, 0.2. All of those numbers are greater than 0. All those numbers are less than 1, so they're all probabilities. And if we were to add up all these numbers, they would sum to 1. Since they sum to 1, this is a probability distribution. What about the next one? Okay, so the next one has a negative x in there, and that's okay. X's can be negative or positive or whatever. All these probabilities are between 0 and 1. There is one that's 0, but that's, again, okay. You're allowed to have probabilities that are 0. And if we were to add up all these probabilities, oops, sorry about that. If we were to add up all these probabilities, they would add up to 1. So this one as well is a discrete probability distribution. What about the next one? So we're looking at the next one here. All these probabilities look okay until we get to this one. This one right here is negative, right? That's not allowed. You're not allowed to have that. Sorry about that. Try to get this mouse to work properly, right? So that's not allowed. Since that's not allowed, this is not a discrete probability distribution. What about the next one? Let's see. All these probabilities are positive and all of them are less than 1, so that's okay. Let's see. If we add up these probabilities, we actually get 1.1, I think. Well, definitely it's going to be more than 1. So being that it's more than 1, this is not a discrete probability distribution. This is not allowed. All right. Going to the next slide. The expected value and standard deviation of a discrete probability distribution. To find the expected value of a discrete probability distribution, you're just going to take each x value and multiply it by its probability and then add up all those numbers. So there you go, that's the formula. The standard deviation is a little bit more difficult to calculate. It's similar to our standard deviation formula from before. We're going to take each x value, subtract off its average, and then square it. But then instead of adding up that, we're going to first multiply it by its probabilities and then sum everything. And that will give you the variance. And then as we know, the square root of the variance will give you the standard deviation. All right, so let's do this. Let's find the expected value. So let's look at our quiz scores from earlier. So we know our formula, and here's our probability distribution. So first thing we want to do is we want to take each x value and multiply it by its probabilities. So 0 times 0.28 is 0, 1 times 0.08 is 0.08, 2 times 0.2 would be 0.4, etc. And so there we go. Now that we did the x's times the probabilities, we're just going to add them all up, and we get 2.04, and so that's the expected value. So in other words, the average number of correct responses on this quiz is 2.04, just over 2. The question's correct. To find the standard deviation, it's somewhat of an involved calculation. Let's look at the quiz scores from earlier again. The variance is that formula. The standard deviation is just the square root of the variance. Let's look at the probability distribution. So first, according to this formula, we have to do x minus the average. So let's do that. So 0 minus the 2.04 we found earlier would be negative 2.04, and then again doing the same for the rest of these. Okay, after that, we have to square each of them. So let's square each of those values. And keep in mind when you're squaring a number, you're going to wind up with a positive number. So all these should be positive. Then we have to multiply them by their probabilities. So there you go, and then add them all up. This number at the bottom, that's going to be the variance. So the 2.4384 is our variance. And then we square root the variance and we get 1.6. All right, just a few quick notes. You could actually do this in a calculator, in a TI-8384. The same way we found the mean and the standard deviation before, you're going to go through the same menus. In list 1, you're going to enter in your x values, but in list 2, you're going to enter in your probabilities. Then you go to Stat, Calc, one variable statistics, again just like before, but this time in the frequency list, you're going to put in list 2. Then click Calculate, and this will tell you the expected value, the mean, and also the standard deviation. Because this is somewhat time consuming, and it would be faster if you had Excel or if you used a calculator, but I'm not requiring a very fancy calculator on the test. I'm not going to put this question on the test. I'm not going to have you find the standard deviation of a probability distribution. Okay, that's all I wanted to say about that, but I still want you to know how to do it because it is an important skill. So do try it for your homework. Okay, let's look at a more interesting example, one with home insurance, or at least I find this interesting. Simple example, I'm oversimplifying the real world here, but suppose all homes in an area are worth $150,000, and each of these have a 1% chance of being destroyed over the course of a year due to a hurricane or whatever else. So if they're destroyed, the insurance company will reimburse them the entire cost of their home, and again, I'm assuming there's no deductible, I'm just making this as simple as possible. And suppose that the premium for this home insurance premium for the home insurance is $2,000. So in other words, the homeowners will pay the $2,000 no matter what happens. So a good question to ask is, from the insurance company's perspective, are they making money or are they losing money? And if they are making money, on average, how much money are they making per policy they sell? This is an important question because obviously if they're losing money, they shouldn't be doing this. And if they're making money, they have to make enough money to justify even wanting to be in the business because, of course, there's other costs involved, such as paying the salesperson. So let's just explore this calculation. The x values, well, let's look at these two situations that are possible. The one situation is that nothing happens to the person's home, and the other situation is that they file a claim. In other words, they lost their home. So if nothing happens, then the insurance company will make $2,000 and they'll be happy. Most of the time this is going to happen. 99% of the time this will happen because only 1% of the people will file a claim. All right, the other calculation is a little bit more tricky because if the insurance company has to pay for the whole value of the home, they're losing $150,000, but they still got the $2,000 premium, so their net loss would only be $148,000. All right, and the probability of that happening is 1%. So you're going to create this table first, and then according to the formula, we have to take each x and multiply it by its probabilities. Doing that gives you 1,980 for the situation that will happen most of the time. And then the negative 148,000 times 1% gives you negative $1,480. All right, so adding these two numbers up, you get 500. So that's the expected value. On average, the insurance company makes $500 per year for every policy they sell.